Hello, welcome back. So, so we were talking about the substitution and income effect, and related with this, we talked about the compensating variation and income, the equivalent variations. So we'll continue to talk about the consumer theory today. So I realized that we didn't really talk about the demand curve uh, explicitly, but we sort of actually talked about this. So I'll get to that. Okay. Where is it? Okay. So so what's the demand curve? Okay. So demand curve is so how did he derive the demand curve? So 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 we talked about how to draw the um, um, is it really vertical? Yeah. All right. Yeah. So let's say this is the demand curve, um, and this is indifference curve. Then suppose the price changes to this one, um, and then we can think about um, uh, the substitution effect and the income effect, right? All right, so this is not the best picture, but I'm just doing my best. Okay, so, oh, yeah. All right, so this is the substitution effect, right? And then if you extend it to the y-axis, right, so let's see, so if I extend it to the y-axis, we can see that um, then we can compute compensating variation here, right? So that's what we have done. Um, and then, of course, in the end, your your optimal consumption, your real optimal consumption will be somewhere here, right? Um, so how do I do that? Okay, let's see. Hmm, yeah, maybe I'll use a different color style. Okay, so this is the final consumption of X, and this is when we consider only the substitution effect, and the original consumption was somewhere here, right? So, uh, okay. So if I see it here, so here the axis was the here this was um, all right. So this was a commodity X, and this was commodity Y, right? So we're drawing different picture, but similar. So the x-axis is the how much you consume X, and y-axis is the price of X, right? So here, so the situation is the price has gone up. Okay, so let's say from $3 to $5, something like that. Okay, so then so that means initially um, the price was $3. Okay, it's $3, and price has gone up, so that means ah, right, so this no initially $3, right? And then price has gone up like $5 here. So the price will be $5 here, right? Okay. So what I see here is that if we think of the only the substitution effect, the demand curve's gonna look like that, right? And if you think about the total effect, the demand is gonna be like that, right? It's because when price goes up from $3 to $5, the consumption changes from the black dot to red dot when you consider only the substitution effect. And if you include every effect, income effect, and the substitution effect, the changes from this black dot to the blue dot here. Okay, so we see that we can draw two demand curve. I mean, of course, the blue one is the real demand curve. Red is only a hypothetical demand curve. Um, but this can be useful in the sense that when we ignore the income effect, you're looking at yeah, I mean it's really hard to explain right now, but sometimes this red demand curve delivers um, more information about economic agents' behavior. So anyway, so this red dot is called a compensated demand curve, and the name is, of course, because when we think of this red dot, this is like the where the income was compensated by the amount of the compensating variation, right? So this red dot is a hypothetical point, it's not a real point, right? So you're compensating the income so that you're at the original utility level. So if that's the case, the demand curve will be called compensated demand curve. And or sometimes this is called, another name for the compensated demand curve is Hicksian demand curve, because Hicks was the first one who thought about this one. And the blue one is called just the demand curve, but sometimes it's called Walrasian demand curve. Okay. Okay. So yeah, so these are the demand curve. So here, the Wallachian demand curve is flatter than the compensate demand curve, right? So why is it flatter? So what does it mean that demand curve is flat? That means for the same change of the price, the demand is reacting more than the compensated demand curve reacts, right? Because the quantity changes larger than the quantity change in the compensate demand curve, right? And this is not coincidence because the demand is including the income effect and the substitution effect. And when I drew this picture, I drew it so that this good X is a normal good in the sense that when income goes down, the consumption goes down. So it's a normal good. And of course, the substitution effect is always negative, right? Um, right? Yeah. So the income effect is the same direction as the substitution effect. So when I draw the demand curve, it's gonna be flatter because it's reacting to the price change more than the compensate demand reacts to the same price change, right? So if it's not a normal good, if X is an inferior good, then we can expect that the demand curve is going to be actually steeper than the compensate demand curve, right? Because if it's a inferior good, then the income effect is going to neutralize the effect of if neutralize some of the substitution effect, so that the reaction to a change of the price when you consider the normal demand, the Wallachian demand good, Wallachian demand curve will be less. So let me draw that in the next page. Yeah. So let's see. So let's say okay. Okay, and right, and the price has gone up here. Okay, and okay, uh, okay. So so this is the substitution effect, right? So if I have to draw that the same way as in the previous page, this is gonna go like that. Yeah, and black one is gonna go like that. Let me see. Yeah. And let's say the income effect is like that. Right. So what's going on here is that the substitution effect is this one, and the income effect is this blue one. Okay. So what's happening here is that so here's a x, and here's a price of x, and here's x, and here's y, right? So here, so this is say $3 as before, and here's a $5, and the blue one is okay. So this is the case, right? So here the actual demand curve is, so the demand curve goes like that, right? So the previously the original demand curve was demand was at this point, and when I think of the total effect, your demand goes down like that, right? So this is going to be the demand curve, or variation demand curve. And if you think of only the substitution effect, it's going to look like that. Okay, so this is going to be the compensated demand curve, or sometimes it's called Hickshian demand curve, right? So as you see, the compensated demand curve is flatter because, so in other words, when I ignore the income effect, the, the response to a change of the price is larger than the response to the price change when I include the income and the substitution effect. And this is not a coincidence, right? Because the income effect is going to the opposite directions of the income effect, right? So it's gonna neutralize some of the substitution effect. So income effect is gonna neutralize some of the substitution effect, so that demand is gonna be so demand curve is gonna be less response to the price change, right? Because when price goes up from 3 to 5, the demand decreases by this much. But if you think of only the Hicksian demand changes this much, right? Because income effect is neutralizing some of the income effect, right? So that's the case. Um, so what else? So the next thing we can consider is, what if the substitution, the income effect is the opposite and is huge, right? Okay. Um, so let's say this was the original demand curve, the budget line, and this was the optimal decision, and the price is changed into, did I use the red one? Yeah. So probably I need to change this one here. Yeah, probably. So I need to. All right, so let me just. Oh shit. Okay. Okay. All right. So this is the optimal decision. And where's gonna be the um, substitution effect? It's gonna be somewhere here, I guess. Yeah, it's not really easy to see, but yeah, I guess I'm not a Michelangelo. Yeah, but this is too bad, really bad. This is really bad. I need to redraw that. Right. Yeah, this is really bad. Okay. Uh, okay, still bad. All right. So anyway, this is the substitution effect. Um, so here, so here, this is the substitution effect, and the original consumption was here. And then let's say the optimal decision uh, is new optimal decision is, no, this is not the one, sorry. Okay, so let's say your optimal decision is here. Okay, so what's going on here is that okay, um, um, okay, so here previously the price was at $3, but now price is $5, right? So the initially your optimal decision was at this point, at this black dot, and when you think of the substitution effect only, the substitution, the compensate demand will become 5. Okay, so this is gonna be what? So this is gonna be the compensate demand curve, right? So so this is the substitution effect. This is the substitution effect. No, sorry. No, this is the substitution effect, right? From black one to the red dot, right? And the income, if so, if you include the income effect, so this is a very much inferior good, right? Because when income goes down from this one to this one, when income goes down, your demand actually goes up a lot. And the income effect is going to the opposite direction of the substitution effect, and it goes very much opposite, and the magnitude of the income effect is larger than the substitution effect. So in the end, your optimal decision is actually larger than the original consumption. So you end up having uh, um, a positive sloped demand curve. So this is an upward sloping demand curve. So in other words, when price goes up, you consume more because the income effect is um, going against the substitution effect, and the magnitude is even larger. So this is how things come out. So so what do I get from here? So what do I get from here? So um, so I did I talk about the Irish famine in history? So in old days, I don't know when it was, maybe 18th century, 19th century. I'm really bad in memorizing the numbers, historical numbers. Uh, so I'm not sure if it's the 17th or 18th or 19th century. Anyway, long time ago, the Irish people were very poor, and the only thing they produced was the potato. So those are the main export of the island. So most of them were exported to the England. Um, and one year, the winter was really, really cold, so they couldn't really grow the uh, potato well. So in fact, the production of potato went down so much, and that was the so what happens? Supply is going down, so the price goes up. So the price of potato has gone up so much, and when price goes up, what do you expect to happen? People consume less of them, right? So that's what people have expected. But it turns out that the Irish people ate more potato than before. So price has gone up, but they consumed more of the potato in Ireland. So that's so this picture is explaining that kind of. So this is a theory how that historical phenomenon was possible. So what's going on here is that um, the substitution effect is no, so I shouldn't say substitution effect. So here the when income goes down, you're consuming more of the good X here, right? And the increase of the consumption of X is huge, so that is the magnitude is larger than the substitution effect. And of course, the sign is the opposite. So one way to explain the Irish famine in the history is that they were so poor, so basically they have nothing to import to England because they didn't have enough potato to export, right? So, but so they're poor, and when they're poor, you eat only the cheapest food. So now you cannot afford eating some protein or the fat. All right, so you're gonna live on just the cheapest food, which it turns out to be potato. So they're so poor, so they ate only the potatoes because potato was an inferior good, right? It's not a normal good, it's an inferior good. So when you have more money, you tend to eat less of potato because there are better, more delicious food like meat or I don't know, fancy things, right? So this is one explanation why this Irish famine was there, why that kind of phenomenon happened during the Irish famine. Um, I mean, of course, this is only one explanation. There are many other explanations, and some historians think that the record of the Irish famine and the eating more of the potato is just a incorrect description of what happened. So some historians don't believe that actually happened. But anyway, so this is one of the explanation. Okay. Yeah. So here previously, when the the good axis are normal good, the demand curve is flatter than the compensate demand curve. When X is a inferior good, but only a little bit, then compensate demand curve is flatter than the demand curve. So that makes sense because the income effect goes against the substitution effect and the effect is small. And if the income effect is going to the opposite direction of the substitution effect and the magnitude is large, then we may end up having the upward sloping demand curve. Okay. One other possibility we can think of is knife edge case of the second and the third example. So, so one thing we can think of is, so suppose, um, so suppose here's the optimal decision, and price goes up. Okay, and what else? Um, what else? Yeah, and this is the substitution effect. So here's the substitution effect, and the original consumption was here. And suppose the income effect is the opposite of the substitution effect, and the size is exactly the same. So in other words, your optimal decision is somewhere here. Okay. Yeah, I mean, of course, the indifference curve cannot really go down here, but I'm not Michelangelo, so anyway, what's going on here is that the substitution effect is the negative direction as usual. So when price goes up, you reduce the consumption. And the income effect is the opposite direction of the substitution effect, but magnitudes are exactly the same. So this is like the knife edge case between the second and the third example, right? So if this is the case, what happens is that what happens here is that the compensated demand curve is given by the, so this is a variation demand curve, and the the this is going to be the, I'm sorry, so this is the variation demand curve, right? So this is actually the compensated demand curve, right? So we end up with the compensated demand curve with a negative slope, and the Wallachian demand curve becomes just a vertical line because the income effect completely neutralize the substitution effect, but not more than that. So they cancel out the effect. So this is a very funny commodity, right? So basically, whatever the price is, your consumption is still remains the same. Okay, so maybe it's like the water, you have to drink water whatsoever, the usually the fixed amount. So yeah, so this is an example. Okay. Right. So far we were talking about the consumer theory. So I'm finishing the real basic of the consumer theory today, and this is like the most important thing you have to know for the rest of your college life. Okay, every economics course you're gonna take is an application of what we have covered the last 5 weeks, right? This is it. So you have to understand this one very well. Otherwise, you're gonna suffer a lot. This is the basic, okay? Labor economics is about the supply of the labor or demand labor in the firm level. It's all based on this kind of logic. And another reason you have to really get to understand this thing is because we're going to cover the producer theory in a few weeks, and I'm going to talk about a variation of the model we talked about so far. And they all look very similar to what we have done so far, but only similar in the sense that they are not exactly the same. And when you see two different things that are not the same, it's the perfect recipe for confusion. So you might be confused so much if you don't really understand in detail what's going on in this most basic consumer theory. Okay. So if you don't have it, if you don't have the perfect understanding of what's going on in this most basic consumer theory, you need to stop playing this video and go back to the previous material. And you really should finish understanding all these things. Then you can move on. Okay. So the first 6 or 7 weeks is the most important part of this lecture. And actually, it's going to be the most important part of time for your next 2 years of study. Okay. Um, all right. All right. All right. So so we're gonna move on. So we are going to talk about the so-called endowment model. Okay. So what we were so the basic model we were talking about was the following. Okay. So you wake up in the morning and you find the income in your pocket, and you go to the market and you see prices. Okay. And you see the prices and you buy things and come home and consume, and you die. Okay, so that's the model. So this is the basic model we were talking about. So this is a very simple 1 day model. So you wake up in the morning, you're basically born in the morning, and you find some income in your pocket. You go to the market and you see prices of the commodities, and you buy certain amounts of certain goods, and you spend all your money and come home and eat all of those things you bought, and you eat them and you feel happiness and you die. So that's the basic model. And even though it looks very basic and it's very simple model, this can be very easily extended to multi commodities and multi periods. So you don't have to live only 1 day, you can live forever, for example, or many days. And I can incorporate thousands or millions of communities in this model very easily. Okay. So the model we're going to look at, which is called endowment model, is a slightly different. So what I find here is that I find the endowment of X and Y in the morning, and you go to the market and you do the same thing. Okay. So all these things are exactly the same. Okay, it's the same thing. Okay, you're gonna do the same thing. The only difference is you're born with the endowment instead of money. Okay, so for example, you can be born with a 5 units of a good X and 3 units of good Y. So instead of buy, you can also sell. Okay, so you're gonna do buy and sell. In other words, you can trade. Okay, so that's the difference. So instead of money, you're born with the things and you go to the market and then you consume and you feel happiness and you die. All right. So let's see. So now, what's the model look like? All right. So here is good X and good Y. Okay. So suppose you're born with the 5 units of three and the 3 units of Y. Okay. So this is your endowment. So one thing you can do is you don't have to trade anything and you can just eat it. All right. So let's say this is saying, all right. So let's say this is the indifference curve. So let's say this is the indifference curve the passing that's passing through 5 comma 3. Okay. So if you don't go to the market, or even if you go to the market, you don't trade, then you can achieve this amount of a level of utility, right? Um, but you can also trade. So let's say px over py is let's say 2 over 1. Okay. Um, then what can you do? So so let's say so this is a 5. So let's say you're decreasing the consumption of X from 5 to 4. All right. Then how many units of Y can you buy? 2 units, right? Because the ratio is 2. So for example, and maybe this is $6 and $3. So if you sell 1 unit of the X, you can buy 2 units of Y, right? So that means I can go up to 2. So this point will be 4 and 5, right? So 1 unit direction, 1 unit, I'm sorry, subtraction, right? So 1 unit reduction in X, and that means 2 units of increase for Y, right? So that means, um, okay, so this is the budget line. Okay, so this is the budget line. So the slope is of course 2, right? So you can move along the budget line if you like, right? You can move along on the budget line, right? So that's the so in the end, where is going to be the optimum? So optimum will be I know somewhere here, I guess. So your optimum will be somewhere here. Okay, so that's where MRS equal to the price ratio. In other words, the slope of the indifference curve is equivalent to the slope of the budget line. Okay, so that's going to be your optimal decision. So um, so how do I so starting from the initial point, how do I go there, or how do I go there? It's very easy, right? So here, um, when so let's say your initial endowment was 5 and 3. Okay, so what's going on here is that, so let's say X comma Y is your consumption. Okay, then X minus WX, what is going to be this one? So X is the consumption, WX is how much you have. So if this is a positive number, that means you're purchasing this much of a good X from the market, right? So this is what you already have, and this is what you're going to consume. So difference, you probably have to buy it from the market, right? So how much, so what's the expenditure on this additional purchase of X? So this is going to be the expenditure on X, right? And where does the money come from? Well, you probably have to buy it from selling Y, right? And if you sell Y, then your final consumption Y will be probably smaller than how much you had in the first place, right? So this will be the revenue. And this is going to be expenditure on so let's say on okay all right something went all right on additional X minus WX, right? So this is gonna be the expenditure, right? And they have to, okay, something went wrong. Okay, so now it's back. Okay, so that's, so I mean, so expenditure equal to the revenue, so that has to be the case, right? Because you're gonna die at the end of this day, so why not spend all your money, right? So this is gonna be the one. So if I rewrite it, this is becoming what? Px times x plus py times y is equal to px times wx plus py times wy. Okay. Equivalently, we can think about the case where you actually sell some amount of x. So this is your consumption x, and this is the how much you had x in the first, how much of x you had in the first place. So this will be the sales of the x. So this thing is the revenue from the sales of x minus x, right? And what's going to be the, and using that money, I can buy more y. So this is how much you had. This is how much y you had in the first place. And this is how much you are going to consume in the end, right? So this is the additional amount of y you need to buy. So multiplied with the price, that's the expenditure on additional y. The amount is y minus wy, right? So they have to be the same. And if you rewrite it, it comes out exactly the same thing. All right. So the two things are exactly the same. So no matter what, whether you buy X and sell Y, or whether you buy Y and sell X, the budget constraint looks the same. Okay. And I mean, if you think about the budget line here, that's so natural, right? Because the trade ratio between X and Y remains the same, whether you buy more of X and sell Y, or buy more of Y and sell X, right? So the equations are the same. Another way to think about this equation is that instead of figuring out how much of X to buy or sell, or how much of Y buy or sell, you can think of doing like sell everything you have in the first place and make the money, and using the money, you choose how much X and Y to repurchase, right? So that's another way of to think about this budget constraint. Okay, so you sell everything you have in the market, and then you repurchase X and Y from the market. Okay, so that's fine. So the right-hand side of this equation is measuring the value of endowment you have. It's the value of how much you have, X comma Y. Okay, using the value of what you have, you're gonna buy X and Y. So which is the left-hand side is the value of your purchase or the value of your consumption. Okay, so that's a way to think about that. So other than so basically, the only difference in this second model, the second model is endowment model. So this is the first model, and this is the second model. So the second models, the only difference is that you have the value of the your endowment on the right hand side instead of y, right? So previously you had I, but now it's replaced with a px times wx plus py times wy. Okay, so that's the only difference. Utility function still looks the same. Okay, so let's go back to the slide. I mean, I know I missed some part of the slide, but I'll get back to that later. Okay. Um, so where are we? Yes, yes, the consumer choice with the initial endowment. So the initial endowment is can I write down here something? No. Can I write it now? Never mind. All right. So anyway, so here E1 and E2, so that's the endowment of the first good and the second good, and P1 times E1, that's the value of the E1 you have, and P2 times E2, that's the value of the second good you have. And the right-hand side equation is the value of your consumption. All right, so how do I draw the budget constraint? It's very easy. You first draw the initial endowment, E1 comma E2, and you draw a straight line passing through your endowment. Okay, and I'm sorry. All right, and the slope is going to be P1 over P2 as usual, right? There gotta be a way to write down on this one. Okay, anyway. So what happens to the change of endowment when you have more endowment? So for example, if you have more of the E1 and more of the first good, more of the second good, this picture will represent the change of your endowment, right? So now let's consider two cases, okay? So E is the endowment point, okay? So this is where your endowment is. E is your endowment. And your optimal decision is A, all right? Okay. Now, suppose the price of the first good has gone up. So you know the slope of the budget line is P1 over P2, right? So suppose P1 has gone up. What happens? The budget line becomes steeper, like in the yellow line, right? But it still needs to go through what? The initial endowment, E, right? So if you go through the E with a steeper slope, the yellow line will be your budget constraint. Okay. Um, so your your optimal decision will become B. Okay. So let's see. What is this? Is this a normal good or the inferior good? This is normal good, right? So when the budget goes up from the dotted red line, a yellow line to the solid red line, the consumption of X has gone up, right? So when, so in the end, comparing A and B, what happened? When price goes up, the consumption of X has gone up or gone down? The consumption has gone up, right? Wait a second, what's going on here? So you told me that X is a normal good because when you see the change from S to B, you see that when you have more income, you have more consumption of X, right? That's the case in the first graph, right? So we know that X is a normal good. But in the end, what happened is that when you compare A and B, the consumption has gone up when price goes up. But in the previous model, we learned that when price goes up and X is a normal good, the consumption should go down, right? But now, that's not the case. What's going on here? It's a normal good, price has gone up, but your consumption has gone up. What's going on? All right, so the difference from the first model is the following. So in the first model, income is given. No matter what the new prices are, income is given number. Income doesn't change depending on the price. But here, that's not the case. When price changes, the value of what you have also changes, right? So that's the crucial difference between the first and the second model. So for this person, for the first graph, for this person, he was selling X, right? So if you compare E and A, you can see that his initial endowment is larger than his consumption for X1, for the first good, right? So he was selling the first good and buying the second good using that money. Now price has gone up. What happens? That means the value of his endowment goes up, right? Because he was selling the good, selling the first good. So it's like he has more money than before. So using that extra money he has, he's basically increasing his consumption. Okay. So this is not really contradictory to the prediction of the first model. It's just that the income is changing in P. That's it. When prices change, income changes. So because of this additional effect, we can have upward sloping demand for the for normal good, right? Because that's what's exactly going on here. X is a first good is a normal good, but demand goes up when price goes up. So some people say this is what happened in Ireland in 17th century, 18th century, or 19th century. I don't know when. Okay. So I mean, if you think about that, Ireland was the main exporter. I mean, mainly their main export was the potato. So the potato crop was really bad on that specific year, so that price has gone up a lot. So each household who didn't screw up the crop of the potato might have more income. So if you have more income, what are you gonna do? You're gonna eat more of the potato if potatoes are no more good, right? So the explanation here is actually quite different from the previous explanation, right? Because this explanation rely on the fact that the potato is an important part of the income. So even if the potato is a normal good, this model can predict the increase of the consumption of potato. when price goes up. So, so this is looking at different channel how the consumption of potato can go up when price goes up. So this is looking at this channel of the income. On the other hand, the previous model looking at the channel of the normal good or the inferior good, right? So these two explanations are a different explanation. I mean, of course, what really happened is probably a combination of the two, but I'm just saying that the explanation is quite different. Let's look at the second graph. The second graph is what's going on. So here the endowment is at E, and we're looking at the case where PX goes down. So now the budget line becomes flatter in the yellow solid line. So your optimal decision is B, and let's say S is representing the substitution effect, and the income effect is from S to B. So what's going on here is that income goes down and the consumption goes down from S to B. So this is the normal good case, right? Normal good consumption goes down when income goes down, right? So again, this is a normal good, but what happens here is that when price goes down, the consumption when price goes down, what happens? Consumption goes up. So this is so the prediction is the same as the previous model. Why? Because this guy was why? Wait a second. So price goes down and your consumption goes up. Yeah, so here the substitution effect dominates the income effect. So well actually, yeah, so the directions are the opposite. So as you see here, the income substitution effect is from A to S and the income effect is from S to B. So they're in the opposite direction, but the substitution effect dominates. So we get similar prediction like the one in the first model. Okay. So this is the basically the illustration of the endowment model. Okay. So now so the major application of the endowment model is a leisure work trade-off. Okay. Um, so this is a special case where all income comes from selling 1 hour's one's labor at the given wage rate W. Okay. So here there are 24 hours in a day, and this must be divided between labor and the leisure. So, for example, capital T can be 24, and capital L is the labor, and the L is the leisure. Okay. So so this person, yeah. So maybe it's better to write down using the scratch paper. All right. So here, so this is well, what is the title? I forget. Leisure work trade-off, right? So leisure work trade-off. Okay. So you have a total hour of 24, for example, and you're dividing into the work or the leisure. Okay, so this stands for labor, stands for leisure. Having fun. Okay, and what's the so if you work capital L hours of L hours, then this will be the income. So this will be the income, and using that, you're going to consume uh, composite good. So the price of the composite good is $1, right? So I'm just writing down as Y. Okay. And the utility function is a function of leisure and the composite good, right? So remember that this is quite funny utility function in the sense that um, the labor is not in the utility function, right? Because if you I mean, yeah, that's probably not the right way to say it. So small l is a t minus l, capital L, comma y. So in a sense, leisure and the labor enters exactly a reciprocal way. So kind of a leisure and the labor is combined into one variable. Okay. So anyway, so let's say this is a utility function. Okay. So this is a utility function and this is the budget line. So if I rewrite the budget line, um, I can write that this way. Okay. So I replaced capital L with the capital T minus a small l, right? And this can be rewritten as WT is equivalent to W times small l plus y. Okay. So what does it mean? So I mean, so the meaning of the this blue box, the equation is clear, right? So you work capital L hours and you make a hourly wage of W, so W times the capital L is the your total income. And using that money, you're consuming the composite good. And the price of the composite good is $1, right? So different way to think about that is the following. So you have 24 hours of so you're selling the 24 hours at the hourly wage W, and using that money, you're purchasing the leisure at the same W. Okay, so in other words, leisure's hidden price is W, right? So if you take one more hours of leisure, that means you're giving up 1 hour worth of the wage, right? So in that sense, W is the opportunity cost of the leisure. Because if you relax one more hour, you're losing a W dollars, right? So one way to think about that is your endowment, the value of your endowment is W times capital T. So that's the whole value of hours you have, 24 times W. And using that money, you're gonna buy consumption Y, composite good, consumption Y, and you're buying the leisure at the opportunity cost W, right? Because 1 hour spent for playing computer game means 1 hour of worth of the wage given up, right? So in that sense, um, we can write down the budget constraint like that. So I mean, I'll talk about this opportunity cost more when we talk about the production theory. But meanwhile, we'll just leave it that way. Okay, all right. So this is it. We have a budget line, and then we have a utility function. Now we're ready to draw the graph. Okay, so this is the y-axis, and this is x-axis. So the second good is a composite good, and the first good is what? Leisure, right? Um, so what's the intersection of the budget line with the x-axis and y-axis? So this one will be, so if you um, um, uh, buy only the leisure, so that means you're spending all your 24 hours on the leisure. That means you don't have any money, so that your consumption of the composite good will be zero, right? So this point is 24. On the other hand, if you take zero leisure, that means you're working 24 hours. that means you have 24 times W as a money. So this will be the how much you can spend on the composite good. And indifference curve are like that. Okay. All right. So this is it. Now let's think about the changing the prices. Okay. So suppose W goes up. Okay. So let's say it's from three. So let's say it goes up from $3 to $5. Right. This is how we draw. This is how we used to draw the change of the budget line. Right. Is it correct? No. This is completely wrong this time. Why? Because you need to draw the budget line at the endowment all the time. So what is the endowment here? The endowment here is 24 and 0. So you have 24 hours, that's all you have. And you have a zero composite good. In other words, you have no money at all. And that point is here. So this is the endowment point. So whenever you draw a new budget line, it has to go through the endowment. Okay. So this change of the budget line is different from what we had for the first model, right? For the first model, the budget line change was always like that, right? So budget line change was a rotating budget line with the hub centered at the intersection of the budget line and the y-axis, right? But that's not the case here anymore because previously the endowment was on this blue dot, right? Because the composite good was measured in dollars, right? And your endowment was a dollar money. So the endowment was always at this corner. But now the endowment doesn't have to be there. And in this specific leisure work trade-off model, the endowment turns out to be um, uh, at the intersection of the budget line and the x-axis, right? So, so this is going to be the your budget line, right? So what's the substitution effect? So the substitution effect will be okay. Okay. So the substitution effect will be okay. So the substitution effect will be here. So the originally the consumption was here, but this is the substitution effect, right? Now, so what's the income effect? So the income effect is now you're looking at the decrease of the income. Um, so now you're looking at the decrease of the income. So well, it depends. I mean, it'll definitely decrease, but how much it does depends, right? So let's draw the demand curve. Oh, okay, so the demand curve is so okay, let's see. So initially this was the demand, and now the substitution effect is looking at this line. Oh, what happened here? Okay, so substitution effect is looking at this line. Um, so um, so if you are on the left hand side of this point, uh, leisure is a normal good, right? So it's a normal good. So so previously, So let's say the price was I don't know, what is the price change? Yeah, so let's say wage was $3, right? Now the price has gone up, so the wage has gone up to $5. Okay, so previously you're at the I'm sorry, not this one. So you're at this point now. Let's say leisure is the normal good, so the optimal decision will be somewhere here. So optimal decision will be somewhere here because leisure is a normal good. So let's say suppose the optimal decision was here. Okay, suppose the optimal decision is here. Then what happens? Then what happens is that your optimal decision will be here. So what happens? You're gonna have increase the upward sloping demand for the labor, right? Okay. Now suppose this was not the optimal bundle. Okay, so suppose um, let's see suppose your optimal decision was at this point. Okay, all right. So probably this is not the best picture, but something like that. Okay. Then your optimal decision will be um, in a price quantity picture. Your optimal decision will be here. So this will be the demand for the leisure. Okay, so here um, XX is leisure, and this is the price of the leisure, right? Okay. So, so if the second is the case, then what we see here is that the the demand for the leisure looks like a regular demand curve, downward sloping one. But if it's only a slightly normal good, then we have a increasing upward sloping demand curve. Okay. So so if the endowments we see this kind of weird picture. And so what's the consequence of that to the labor market? So the consequence of this one to the labor market is yeah, I probably should have written down in the same graph, but yeah, I'll just you know what, I'll just copy and paste because I'm lazy. Yep. Okay. All right. All right. So suppose this is the case. Okay. Um, yeah, I'll probably need this one. Okay. So so let's look at the capital W, capital L. all right? Because the price of the small L and price of the capital L, they're the same, right? Because the wage is the opportunity cost of the leisure, and wage is the wage for the labor, right? So, so labor and the leisure, they're reciprocal because L plus small capital L is the 24. So when L goes up, what happens to the W is that, so suppose this was like, say, 5 or 7. Doesn't make sense, right? Because 5 hours leisure means you're working 19 hours. That's hard to imagine. Well, let's say 15 and 17, okay? Then what's happening with the labor supply is the following, right? So that is, this will be what? So this will be, um, so at when wages are $5, the demand for the leisure is 17. That means the labor supply will be 7. So the 7 plus 17 becomes 24, right? So on the other hand, when wages are $3, the consumption of leisure is 15 hours, right? That means the supply of the labor will be 9 hours, right? So that 9 and the 15 adds up to 24, right? So what happens here, so this becomes basically the labor supply curve. Okay, so what's going on here is that when wage goes up, the demand goes down. I'm sorry, the supply goes down. So that's the opposite of the regular supply curve, right? So no, usually the supply curve is upward sloping, right? When price goes up, people tend to supply more. But here, the opposite is happening. When price goes up, you're supplying less. Okay. So of course, this may not be the case, right? If we think that the second picture is a more regular one, then that's not gonna be the case, right? So here, um, so if you think the second is a more natural one, then what's gonna happen is that, uh, oh, yeah. So then, what's gonna happen is that, so let's say this is 14, and this is, let's say, uh, uh, 18. Then what happens? Then when the wage is $5, when wage is $5, you're working, your leisure is 14 hours, right? So that means you're working, how many? 10 hours, right? So that's like a 10 hours. On the other hand, when wage is $3, your leisure consumption is 18 hours. That means you have only 6 hours to work, right? So 6 hours to work here, right? So this is gonna be the labor supply. Okay. So yeah, so depending on the picture, we may have a upward sloping labor supply curve, like all the other supply curve, or we may end up with the downward sloping labor supply curve. Um, yeah. So, basically we need to look at the data to determine which is the right shape. So we don't know that, but I'm just saying that anything can happen with the labor supply curve. So in fact, certain economists think that the labor supply curve looks like this. Okay, so in other words, when wage is relatively smaller, when wage is closer to zero, we tend to have a regular labor supply curve in the sense of upward sloping labor supply curve. On the other hand, when the wage is high, uh, the labor supply curve is downward sloping. So that's kind of a crazy supply curve, right? So I mean, I can see that. I mean, if your wage is very high, then you probably don't want to work too much, right? What are you gonna do with the more additional money? I mean, you need time to spend it, right? So I can imagine that if your wage is really high, you probably wanna relax more than work more, right? But if you don't have but if your hourly wage is very low, if wage goes up, that's a very good opportunity to make more money, right? Because you don't have enough money anyway in the first place. So it makes sense to have a upward sloping labor supply curve. Okay. All right. So let me finish the lecture today, and in the next lecture, I'll probably talk about maybe we'll have opportunity to look at the past exam questions. Okay. All right. I'll see you later.